right. Well, welcome everyone. I'm here today to talk about LaTeX or LaTeX. Title of this talk is Introduction to LaTeX for helping manage the complexity of your dissertation and more. This is meant to be kind of an introduction to how this works, the kind of philosophy behind it. So we'll be going through kind of a very short introduction of the basics. I'll give you some of the basic commands in the second one. Then, really something that has enabled this, I really think, to be something that I recommend to essentially everyone is a particular freemium product called Overleaf that really enables the collaboration and minimal kind of installation process for using this approach. Some of the problems in the past that if you've heard some negatives about this, a lot of them are addressed with this particular tool as at least a way to get started. So we'll go through that. I'm going to contextualize this through a CSU provided dissertation template. So you're worried about the formatting of your dissertation or how to manage that large document. I will at least give you a link to a template in Overleaf that you could use as a starting point, or at least as a learning tool to see if it's right for you. And then I have some discussion points and then a bunch of resources. My goal for the resources is mostly for you to look at them afterwards if you're, what you see is interesting. The slides will be provided after the fact. But with that, let's get into the content here. LaTeX is a document preparation system for high quality typesetting. It is, itself free software. The core things, if you want to do it without any tools, you just need to write plain text files and run commands on whatever operating system you're on. That's the basics. That's all freely available. But there are many free, premium, and paid supporting products, and more often than not, you're going to want to leverage some combination of tools to fit the workflow that you're interested in, and that's what we'll discuss. Here, some of those additional tools, as well as the resources provides, a couple of links for you to explore that. Now, I want to start with kind of an analogy that may connect with some of you in terms of kind of my opinion on where this sits in list of things available to create your content. So I might initially liken LaTeX versus Word to comparisons of kind of Python versus Excel. Right? Both have their uses. Both, we're going to use them for certain things, and they can both accomplish very complicated things. But once you know the commands, tools, packages within Python, there are certain tasks you will only do through Python. At that point, you're going to be like, why was I doing it in Excel? I can do it with Python code much more efficiently. I can scale much more effectively. I can get the outcomes I want, automate things, etc. All those are types of things that I will argue with in this presentation are advantages of this particular approach. But transitioning from very visual, a very kind of user-friendly thing with Excel to say Python more coding-based, there's obviously challenges that come with that as well. So we'll have a discussion of challenges. Now, before I really get into the content, I want to really encourage you to have a conversation first, especially with your advisor and collaborators. What you see here in this presentation is interesting, and you want to pursue it in your own work. Have a conversation with them. They may have their own preferred tools. They may have their own preferred approaches and opinions on how to use these things. I'll give you some insights or discussion points to bring to them, particularly in this discussion section 4. But the main point, the research is more important than how it's written out. So make sure that you are understanding, does this work for your group? Does this work for what your needs are? You have a deadline. It's probably not a good idea to pick this up and try to write your paper in one day. If you've not explored this approach already, make sure you're understanding, is this right for your research activities and group? Okay, so how does it work? I have 2 slides. The first one is kind of how do we represent the content, essentially. So you write most of your documents in this approach in plain text with commands describing the structuring meaning. The commands are taking that plain text content and going to transform it, or they're representing, I want LaTeX to transform that content in some way. So a LaTeX program processes your content, things like text, commands, images, more. We'll describe some other things to produce a beautifully formatted document. It takes plain content, produces that formatted content. So as an example, and you'll see many examples like this in this presentation, I have on the left kind of what you would write in a plain text editor, LaTeX code that describes the content. Here I have, and these examples are coming from an already existing presentation. If you're wondering why I selected the rain in Spain falls mainly on the plain, there's a really nice presentation that I'm basing a lot of these examples on. That's listed in the resources section. So here, instead of specifically observing the formatting like bold text or italicized text, I define a command that is going to format that content for me. So the left side, plain text, the right side, the LaTeX program takes this plain text and converts it into the formatted content on the right. This is the fundamental philosophy behind this approach is we will need to understand the commands and other things to take our plain text content and transform it. So this kind of approach uses commands to primarily describe what it is in terms of the content, not how it looks. And this will be one of the advantages I'll put forth in the way that things are done in this approach, is that we can focus on the content, we can transform the content into different presentations depending on the context that we want. Now, we'll go through a lot more examples in the second section, but here are some quick ones just so you can kind of think about, this was just text with bold and italicized. We can do other things, and there are commands and environments for doing things like lists, with itemized environments, figures with figure floats, include graphics to include figure files, captions for those figure files, things like that. And then one of the main, at least one of the main drivers for this to be developed in the first place a few decades ago was for writing math. Really is kind of the gold standard of writing mathematics in bringing it into documents, essentially. So here's an example of an equation. Okay, so what's a minimal example look like? How can I create my first document? So as I mentioned, we are writing plain text documents. They're usually, they should have the extension of .tex here. And a complete example, one that will, we can provide to a LaTeX kind of a tool or compiler is as follows. We have a document class article, we have a begin end document, and then we have our content inside of it. So let me go through kind of the things you're seeing here. Commands, again, I'm using that blue coloring to denote commands throughout this presentation. Commands start with the backslash. There's lots of commands. You can find your own commands, things like that. Every document will start with a document class command. You're gonna, this is how we tell it what's the format. In this case, I'm going to use, this is the plain LaTeX article class, and we'll see kind of what that formatting looks like. But there are lots of options. You might have one for AIAA or ASME. Many professional organizations, for example, provide templates for that class argument, and you can put it in and it formats it to that conference, proceedings formats that's desired. So I have a list of those at the end of the slides if you're interested, but for now we're using the plain article. Now, commands can arguments. Arguments are what you put inside the curly braces. Here we're using the document class command. The argument is article. That's the type of document we're building here. We can do things like commands or comments as well with the % sign. This might seem kind of trivial, but I argue, how do you do inline comments in a Word document? Well, they show up in the content. This is one thing that really, I think, separates it, and leveraging the ability to provide contextual information through comments and things like that in these documents. Now I'll discuss that a little bit more, some strategies that I use around that in the discussion section. But comments will ignore the rest of the line. Okay, so how does it work? Part two. That simple example, you might think about adding lots of content, understanding the commands, but really, kind of a comprehensive picture here is your content doesn't have to be one thing. It's no longer one Word file. Rather, it is multiple files. It can be many different text, or many different text files, each of them containing the content through commands and text. Figures even, we'll talk about how to include figures, PDF, PNG, JPEG. extensions for the figures we can include, references as more of a database-centric approach that formats the references automatically for you from that database. Even data, loading in CSV files to format your tables. We'll discuss kind of the implications of having these separated and the advantages it implies. So to do this, we can use commands, additional commands like input and conclude to compose text files. I might input another document inside of my one document. It allows now to start doing things like breaking it up into smaller pieces, and that has a particular that can have a particular advantage in things like a dissertation, right? You have chapters. It'd be great to not have to scroll through hundreds of pages of my dissertation, but rather I can go immediately to that single chapter file, just focus on it. It is decomposing our documents in whatever way we see fit. Now we have these files, we have commands, and together the LaTeX program can compile them together to make that formatted document. Typically, PDF output. For understanding what comes out of this is a PDF that has the formatted content. So here's a visualization of this idea. We have our content, data files, image files. Maybe those are placed within our chapter. We also might have a reference database that we'll talk about. We can have a separate file for the appendices. All those are listed in our main file or some hierarchy of commands that includes them all together, and LaTeX produces a single PDF file compiling them all together. All right, so that's starting point basics, right? We write things like what we just saw on this slide. We have files and essentially multiple versions of this type of thing that can get built together. What are the commands? What are the ways that I can bring together content or describe content using this approach? So basics of LaTeX here. Let's go through. Again, we have about 10 or so slides describing the basics. I have a couple of extra read later slides as well, and plenty of resources that will really let you dive into all the available options. Okay, so the first kind of concept to be thinking about is environments. And this is really kind of the way that we separate content from formatting, and especially formatting in different contexts. So an environment, for example, the equation that we saw in one of the previous examples is a type of environment, it's a context. Now, a particular command, as well as content, can produce a different output, a different formatted output in different contexts. So for example, I have here showing two different environments for writing mathematical equations. We have kind of the inline environment with the $ symbol, where I have this equation and it's formatted in one way, in an inline fashion. I have then this equation environment that I describe with the begin and the end equation kind of delimiters, and I have the exact same content inside of that, and it is formatted differently. It provides an equation number. The context is different between those two environments, but I present the content in the same way. It's not clear, right? Things like the symbol sizes change, and I've added the number, it's equation 2, that type of thing are the types of things that might change between the different contexts provided by a different environment. There's other environments. Again, I mentioned the begin and end commands are used to create many environments. Another common use case here is we want to have bolded lists and itemized lists. Itemized and enumerated environments can help us generate those lists. We have them visualized here with the itemized environment and the enumerated environment. Okay, so the basic LaTeX system provides a number of commands and a number of things that we can do, but another key aspect in terms of the ability to do the things we want to do is that there's a really rich free and generally open source package repository for the LaTeX environment. So all the commands that we have looked at in environments are built into LaTeX. We don't need additional packages. When I described that minimal example, there was no additional packages loaded. Now, packages are libraries of extra commands and environments, other things as well, but that's kind of the main thing they're providing is additional commands and environments for us to do things. And there are thousands of freely available packages. I summarize kind of some simple and more advanced ones on some resources slides that you see later. Now, to use a package, we have to load it. This is where the use package command is required. Use package, with inside the arguments there, you provide the package you want to load. And that goes in what is known as the preamble. It's just a fancy word for the things that happen before the content is displayed, before the begin document. So the one I'm showing here, it's called Font Awesome. It provides 600 web-related icons. You know, I'm creating content for this presentation. This presentation is written in LaTeX. I might want to create some icons or use these icons. This package has them provided for me. I don't need to go find them. I can just use the commands, and the documentation lists out all the icons. So to do this, the kind of minimal example here, still define document class. I will load the package in the preamble, use package font awesome. That goes before the begin document. Then within the begin and end document, I put my content. Now, one example, right here there are three of the commands that provide these three symbols. So again, lots of packages. I will discuss more as we go through these basics, even as some very fundamental things do require a package to be loaded. And again, this CTAN org is how they're freely available. So the documentation is there as well as the raw files if you want to include them, but we'll talk about that. There's usually, using extra tools, more effective ways to load these packages. You don't have to directly find those files and bring them into your project. All right, so continuing, let's talk about structured documents. We often want to define a title and a section and a chapter, things like that, structure the document in that type of way. So there are a variety of default commands for structuring a document: title, author, date, make title, section, subsection, subsection. Those are kind of the primary ones. Often abstracts. The abstracts that we want to include in a document is defined through an environment rather than directly through a command. We'll see this in the example in a second. And then many classes, especially say a dissertation class, will have chapter available. So that's one level up above section. So what does this kind of look like? We look at the content here. There's a lot of commands because we're starting to really structure and define a more complete document. On the left, we're beginning with the article class definition. Content immediately. This does not require any packages. I have the title command, the title. I have author, author. I have the date with another command saying today's date. Make title is the command to take the information that's been defined in those first three commands and build things. So certain commands will leverage information that's already available kind of in the environment that you've built with the content. So it has access to the title information, author, and date, and it will create the title. The in and an abstract, again, an environment for defining an abstract, and you put the abstract content in there, and it will get displayed in whatever class appropriate manner is defined. Section, we have content, next line, subsection, subsection for more content. You've been kind of darting back and forth between the left and right sides. You can see how this is being formatted at the top there. Title, author, date. That is, again, these are the defaults for this article class. They can be customized. The abstract is being shown as centered with the word abstract and then the content below it. Section, it's by default numbered. We can see with the section star, where I said unnumbered section, the star is to suppress the number essentially, or not provide a number for that section. So we can see numbering is automatically done for us. We can see the structuring that we may want is done just through these simple set of commands. All right, so one of the primary advantages I find in leveraging a LaTeX-based approach is the kind of consistent and easy way of doing cross-referencing. So to do cross-referencing, I have something in my document and I want to refer to it in another location in the document. I can define labels. Labels will tag where that is, and then I can use that label to, this is figure one. Where's figure one? Well, it's over here. So label is the command, and then ref allows me to put that, what is defined in label, and reference it. So cross-referencing, automatic numbering, those type of things are enabled. This works with sections and its variants, equations, figures, tables, lists. If you have something that you want to refer to, even just refer to its location, you can define a label, and there are techniques for cross-referencing it in a way that doesn't require you to manage it yourself, right? I build the document, it knows I want the information, the page number changes, it gets updated automatically. If the figures get reoriented in some way, the numbers get automatically updated. It provides a single way to define that type of cross-referencing information and no longer need to manage it. So here's the example. I won't go through every line as I've been doing on all of the other ones. We focus on the section here. We have section, introduction. I've now defined a label for it. Label is your choice, right? There's some often naming conventions, right? I'm going to say it's a section, colon intro, so that I know, first of all, it's a section and it's an intro. We'll see in the overleaf tool, for example, it will create a list of all the available labels. So, right, perhaps prefixing it with section allows it to, you to more easily find what label you're looking for. But you can describe, you can make it much longer if you wanted to. It's your choice. What's the label? All you need to know is what label corresponds to the appropriate location or appropriate thing you're cross-referencing. So here, this section, I'm now referencing the section that it's in. So ref intro is going to, pull for me the number of the section that label's in. But maybe I'm doing a forward cross-reference to the method section, right? I have section method, label, section method, finds the label for that section. So if we look at the content here on the right, we can see this is section 1, but section 2, right? That's the formatting of those labels with the correct numbers pulled from the, pulled from the content defined on the left. Again, this can be done with equations. So I have an equation here. Within the equation environment, this wouldn't quite work with the inline equation environment, because one of the features of the equation environment and similar environments is that it provides a number, right? That number is what is then referenced when I reference the label. So let's say Euler equation, I want to reference that by equation ref equation Euler, and that number appears. Okay, I think that's the basis. Again, this can be done with figures, tables, things like that as well, list items, etc. We'll see some of that in some of the examples. Okay, so speaking of figures, figures is something that does require a package that probably almost all LaTeX projects will load this graphics package. It provides this include graphics command. This command supports a variety of graphics formats, PDF, EPS. I'll strongly encourage that using lossless image formats is very easy in the context of LaTeX workflows, which is a advantage I really like of it. I don't have to can define things as PDFs and just load them directly in as my image. It works well for the things that I create, but you can still do PNG, JPEG, rasterized images as well. Okay, so the figure environment is a kind of float. LaTeX will mostly decide where the figure will go. It can float. Now, this is something, and there was discussions earlier about this, that this is something that, again, I think there'll be differences of opinion. There is, you deciding exactly where the content goes, is, one way of doing things. I like to relieve myself of that mental burden and let the tool do it, because it is then, designed around trying to present things in, in a certain way. It's, not trying to generally put images in the middle of my text. Rather, let's keep, say, content that is textual together, image content separately, right? We have our robust cross-referencing tools to say, go look at figure 1, and I'll put it at the top. But there are ways to control this. I can put figures at the top, bottom, here. I'm not really going through that here, but I'm happy to, it's in the resources if you look into this package, there are ways to kind of move things around. But in general, there's this concept of floats, and this is something that is fundamentally different than what you see is what you get type of editors where you directly place the figure where you want it to go. So the figure environment is a kind of float. I'm going to put graphics in that figure environment through the include graphics command in this example. So again, I need to use this package. I'm going to show cross-referencing and also kind of the floating bit behavior, because the content's on the left, right? I first write in my content figure, ref, big, logo, shows, dots. So I am describing the figure before I before it is actually in the content. But I've defined this figure float, begin figure. I'm using the centering command to center it. Include graphics, has a few options. You can customize or set the height and width. Height is now set to 1 inch in this case. And then CSU logo. It's an unnamed extension. In this case, it's a PDF, but it will look for, there's kind of a list of orderings it will look for in terms of if there's a CSU logo, PNG, or PDF, it will pull one of them first into your documents, but you can directly specify the extension as well. We can define captions for figures. So we have the caption command as well. Within that caption command, I'm describing a label. So I can label so I can label and then cross-reference the figure. Now, the content in the caption is there as well. Now, the rendering of the content on the right is illustrating the idea of a float, because even though I put the figure definition below the textual information, the article class and its layout engine decided to put it on the top. If I want to put it on the bottom, there's a way to do an argument B that will place it on the bottom. But this is just an illustration of that float idea. It's something to get used to, or something to understand the commands to do the placement that you may want to do. All right. Okay, so that's the basics of including a bunch of different types of figures. Okay. Now, another primary feature of kind of a LaTeX-based workflow is the ability to use BibTeX, and this is or similar type things. Essentially, how it manages references is in a more database-centric format. In particular, a separate file. It doesn't have to be, but generally, you should define a separate file, a .bib file, that's in this BibTeX database format, and then that is giving the LaTeX tool the information on the reference. It will do the formatting for you. That's not something you need to worry about. You don't need to worry about APA styling and worrying and figuring that out. Rather, you just need to provide it the general entries, the general fields for the entries. So there are many different available entry types, for journal articles, for books, for conference papers, for other, other lists of things. I have a link to the comprehensive list at the end of in the resources section. Entries have fields. Content for a book might be the author and the title and the publisher, for example, in the year. So we define entries of certain types, populate the fields with the information on those different entries. Each entry in the bib file has a key. The key is what you can use to reference it in a document. So this is essentially the same concept or similar concept as cross-referencing. We have keys for the different references. I can then say, I am talking about a specific reference. This call 2022b is an example of a key for the reference defined in this this entry that I have here. So if I want to refer to this in the document, I will call, it'll be on the next slide, I will call the cite command on this particular key. So here's an example of an article, right? It's the type is at article, that's the entry type. The keyword is the first thing that we have, and then we have a list of fields. Fields can be whatever order you want. They're just comma separated. There's a standard for what those fields are, for what fields are appropriate for particular entry types. All that is described in one of the resources that I have. So author, title, journal, volume, number, pages, month, year, DOI as kind of a comprehensive set of data fields that need to be filled in if I want to have a complete reference. Now, most reference managers can create an initial BibTeX entry. I will discuss this a bit more depending on time, how much you can read slide 31. So this is not something you have to create from scratch, but rather you can get a good starting point. You might need to fill in some information or modify it a bit to fit your particular needs. They're not perfect is what I'm saying, but especially if you say have DOI or ISBN or archive, or even for some URLs, it can pull that metadata from that identifier and create this thing for you. Okay, so let's use this. So let's include citations now in our document. We have this database-like entry as defined here in the bib file. So we can automatically format the in-text citations and generate a list of references with many standard styles available. There's like hundreds if you really go into the package repository. We use the cite command in the text when we want to include a citation. We include the bibliography command at the end. and a bibliography style to style paths to different, again, I mentioned APA, or maybe you have an IEEE format that you want, right? Different citation styles. There's a bunch of them available. It's a one-line command to reformat your citations in another way, with this approach. So here's kind of a working example of this. I have kind of two entries as illustrated by two different keys here. I'm citing an article first, and then I'm citing a book. I have the reference style, this IEEE style that I've selected. I have a particular bib file. In this case, bib-example is the bib file that contains the reference information. And then it's rendered on the right, and with the defaults of the article class, see reference 1 and reference 2 as numeric citations, and then the formatted citations in the reference list at the bottom for each of those entries. All right. Okay, so final slide on the basics. We can do things like add table of contents to generate a table of contents from the section command and its variants. And the idea that the document has that metadata, has that information in it. There are commands that often can take it and do things that we want with it. There's also a list of figures, list of tables for similar lists in your, say, dissertation. You'll see these in the dissertation example. Now, you can also define your own commands. This might seem a bit scary, but there's some basic ones. I'll show you one here. This is really where you're starting to do things differently and really leverage the full power of this approach. Define commands to do things you want in a uniform, repeatable, and updatable way. Right? Define a command to format some text. What if I want to change that format? Well, I can change just the way that command is defined, and everything that's derived from it is updated. So, for example, I have this new command. My format has one entry in it, and then it has the first input, because there's only one input. I'm going to color it red. So my format, the equation has my formatting applied, then I can apply it to the equation as well. So if I wanted to change this to blue, I just change in one location, red to blue, and the formatting of the entire document gets updated. So it's the idea of do things once, and it can propagate through the document instead of having to go through and find and change and potentially miss some of that formatting kind of changes. And the basic format of new commands is new command, the name of the command, don't forget the slash, argument, the number of arguments, and then the definition that can use those arguments. I don't know if there are questions related or, okay, yes, great. Okay, so again, there's a lot to learn here if you really want to dive into this. I have a couple of other read later slides in terms of spacing and how it works, quotation marks and special characters, as well as tables that in the interest of time, I think we're doing all right, at least in terms of where I wanted to be. Please look at those slides if you, want to learn a little bit more. Okay, so what I just described, can be done on your local machine. Like, it doesn't even really need a text editor. You just need the file and you can build it. But there is this particular tool that I really like in terms of it really kind of opens up this approach to the masses, essentially. It's called Overleaf. It is a website for writing LaTeX documents. Link is there. Most of the features are free. There are some premium ones that I'll describe that are also useful, but you can do everything we just described in the previous sections with this tool. So it does the hard work of getting the environment and running the commands and stuff like that for building or compiling your LaTeX documents. And it shows you those results in a kind of web browser setup. No setup is needed on your end other than go to the website, potentially make an account, a free account. And it's instant access from web browser. So your collaborators don't need to set anything up. You can just send them the link and they can access the document. It's really good for collaboration. This is a main, 10, 15 years ago when I started using this, there's still the paradigm of sending files around. That was not the best way to doing things, or syncing them through, say, Dropbox, Google Drive, OneDrive, etc. But now, this approach will really enable like Google Drive or Google Docs and Microsoft 360 Online type of sharing, where you can do real-time collaboration. You can see edits in real time. You can see their cursors and where they're at, etc. You can do comments and replies in the documents like you would in Word, where you commented and it shows up on like the margin, and you can say accept or resolve those comments. get a list of all the comments for the whole document. It even has a built-in chat. Again, it has a lot of features to enable collaboration directly within this kind of environment. I'll have another slide on this in the discussion. It also synchronizes changes from all authors transparently. So everyone always has the latest version. You're not, someone edits one file and someone else edits the same file. You're trying to merge them together, etc. Rather, at least with this particular tool, you're seeing those edits in real time. People can work on the same document at the same time, the same file at the same time. It also has autocomplete for a lot of the commands we just talked about. For example, what graphics do I have available to put in include graphics? It will make a list for you of what is in your project, and you can then add them by selecting from a list. You don't have to remember where it's located or write the full name out. Same thing for inputs and references and citations as well, based on, again, what's already in your project. It's looking at that data and providing you, say, a list of all the labels in your project that you can select from to, say, create a cross-reference. It also has a visual editor for less code and more visual editing. I don't particularly use this because I'm pretty comfortable with the code side, but this is something that, say, collaborators might find very useful. Is it will kind of do some pre-formatting of the content and let them edit it in a more what you see is what you get type of manner. And there are lots of other features as well. Here are some of the main ones I wanted to highlight at least, and I'll show them briefly in the demo that I have for the dissertation template. Lots of learning materials. Honestly, Overly is kind of a leader right now in terms of presenting learning materials in addition to the tools. So there's this overleaf.com/learn that has a lot of good things, but if you're specifically looking at how to do Overleaf related things, I've put a few things here, and there's more general materials in the resources section. Okay, so and I want to show a particular template. It is modified, but this is a read-only template in Overleaf. You can then copy it and make your own version if you want to, say, start working on your dissertation or play around with some of the features through this template. So this is a read-only Overleaf document that the QR code link will be available in a second. It's based on the one provided by the graduate school. So the graduate school, I think it was in 2017, so it is somewhat recent, did provide resources for someone to create informing LaTeX templates. So what I've done here, though, is I've added some additional project structure and example of some of the things we saw in the basics, so you can see it in action. So it's a little bit, I would call it enhanced from that version, but I do have the link at the bottom for the GitHub repository if you want to just get the files directly. So it does conform to their formatting guidelines, right? You just add the content, right? The hard task / easy task of adding your entire dissertation to it, but it does handle the formatting side. I'll have some examples at the bottom. I'm Mountain Scholar. A number of students from my group have used this and gotten. We only had issues where we tried to do something like rotate a page, and they didn't like that. But the actual basic formatting, title page, things like that, this handles that for you. You don't need to worry about that. The template takes care of that, at least at starting point of the formatting side. Okay, so here is a link to it. I encourage you to either look at it now. These slides will be made available, so if you want to play around with it later. But this is a link to that read-only template. I'm also taking the opportunity to show things that LaTeX can do. For example, there's a nice QR code package where I can generate the QR code just from the link. I don't need to have a separate tool. Talk about kind of the automations and things that are potentially enabled through this kind of package ecosystem. This is one of those packages. And then again, at the bottom is the link to the CSU GitHub, the CSU thesis repository. It is linked from the official graduate school dissertation page, so that you can have confidence that they are actually supporting, or at least they hasn't been updated for a while because it conforms to existing guidelines, but information is there. And then 4 examples of dissertations that my group has written within this template. All right, so give people a second if they want to open it on their own, either online or in the room, and I will click to it and go through a few things. All right, so here is the templates. This away. So I'm not going to go through a lot of the editor. Again, there's a lot of good resources here. I just want to point out a few quick things. On the left, generally, is the project organization that you have and the files within it. You can see I have folders here. I have different text files. Think back to that graphic earlier where I said you have multiple things that can be composed together to make this document. So I've added in, say, maybe you're gonna have lots of figures and data and files for your different chapters. So maybe one organizational strategy is to create individual folders for those different chapters. You can leverage the fact that you have separate files to organize the content in the ways that you see fit. Now, the middle is the content for the file that you selected. I wanted to just go to the class here. There's document class, doctor thesis. There's a master one. There's a bachelor's thesis one. You can see them in the comments here. So this is illustrating in the comments, provide information of what you're looking at, right? Maybe if you're writing a paper and you want to describe to your collaborator why you wrote it one particular way, you can add a comment. They have that context. That context doesn't need to go into the actual paper, but someone who's reviewing it might want to know that information. Leverage comments as much as possible. Okay, and then from that, we get the displayed content on the right. Let me go to the first page. Come on. The Zoom, I do not like the new Zoom bar there. It gets in the way. Okay, so here's the title page formatted for you. It takes the metadata essentially from title, author, email, department. It's defined its own set of commands that isn't populated within the templates. Hopefully that idea makes sense. Again, this is the idea of new classes, new commands, new packages, enable new things to happen. Okay, so again, most of this is based on the main templates. You can see, for example, the generated table of contents, use the table of contents command, tables and figures as well. And then the main addition I have that I help support you seeing actually how things are done is a bunch of different kind of sample commands. It's a little different than the example I showed, but you're seeing how to do formatting of text, how to cite things, footnotes, inline equations, all the different cross-referencing in one line. But I've also enabled some additional packages that I find useful, or at least I recommend to my students that I used in my own dissertation, like a list of symbols. You can create a robust list of symbols. I can have back refs of what page that symbol appears on. It is a clickable link. It will go to that location. So say you define that back ref for the first location where it's defined, you have a very interactive, a very well-connected document, as well as, acronyms. This is another example. So I'm not going to go too much more into this. Other thing I did want to show was the autocomplete. So if I am in the editor, I might say type / again, the autocomplete for commands. If I start typing, item, right, I'll see things that have, start pattern matching with that. If I do things like, say, the cite command, I will see that it's looking at my bid file and I have, in this case, 2 references available. I can then, select one and it populates it. So this is available for, again, commands, cite, ref, include graphics, those type of things. And it's actually pretty smart. If you define your custom commands, those will also appear in that list, which is something that does not really happen in some other tools. They usually have a pre-populated list. Okay, so how do you make the document and how do you get the document? So there's this nice big compile or recompile button here. There's some options, but I press this button. It is doing the task of taking the content and formatting it for me and creating the PDF. The PDF is shown here, right? It's in this editor. There is a download button right here for download. And now I have the PDF. Hopefully this doesn't break things, and what you were just seeing is now available here. All right, make sure I have enough time for the discussion points. Anything else here of interest? Maybe I'll just show the bib file. Hopefully, again, it's another file that's formatted in this database format. Again, broken up things. Maybe let me show the main organization structure that I have put forth here. Right, each chapter is its own input. Then I can have a focus. Yes, you have a question to ask.
What's the difference?
Yes.
Sorry. What's the difference between input and include?
Yes. Common question. So simple answer is includes a page break or a clear page command. It also does provide some efficiency in compiling. It generates separate aux files. You're getting into actually the files that are created. So but it has that fundamental, it's basically creating like a hard break so that it can handle the creation of some of the necessary files separately. Input is a direct copy of the content into the document. It's like if you type the commands out yourself. That's the difference. So for like a chapter, actually, I probably should just do include. It would make sense here, right? Because each chapter is going to start on its own page and it's going to be its own thing. But if you're trying to like, break up sections, for example, in a document, and you don't want a hard page break, use input.
Okay. All right, thank you.
Thank you for the question. Question was about input versus include, in case that didn't come across in the so yeah, dependencies are separate. There's a lot of things here, going through it pretty quickly. Hopefully this will give you an example to play with and walk through if you're trying to do things. The symbols and acronym lists, etc. are there. This is probably let me remove that. Empty input command. Okay, so that's the basics of Overleaf. You can create many projects. You can use files from other projects. So if you have that bib database in one file in one project, you can use that file in another project. No need to define another database. Define one database of all your references, use it throughout your whole research endeavor. All right, I will switch back to slides. I think there are some comments. I don't know if there's a question. Yes, thank you, Jeremy, for the formatting comments on the BibTeX files. If you need things to be, remain capitalized, close it in a curly braces. Yes, thanks for sharing that. And so yeah, the downloading of the files. Yes, thank you, Chuck. If you go to menu, there is a way to download the source files here. So if you want to download your whole project, then go to that. You should see. I'll just click on the link here. You should see, right, it has our whole project structure. All the files are there, includes the class again. Hopefully that answers what you were looking for. That's how you can download, because there's not just one tech file, there's many tech files in the way that it's organized right now. Probably very hard to read on the screen here. All right. Okay, so we have maybe 10 minutes to quickly go through them, the discussion points. So, maybe what you're seeing here already is something that you find, beneficial. I want to summarize some of my opinions here on advantages and challenges associated with this approach, right? It's not a bulletproof solution. There is things to consider here. So one of the main things that's put forth is the content first methodology. It lets you focus, let LaTeX focus on the formatting, you focus on the content, less time spent setting up your templates. If a conference provides that template, 95% of your work is done in getting that conference paper in the acceptable format. You're just adding the content to it. Everything can be done in a text editor. There's limited clicking through menus. As you write, you're writing the content. You're not, figuring out how to, do something. Once you know the commands, at least, again, my opinion is once you know the commands, it's very easy to just do exactly what you want to do. You can holistically modify presentation organization later with commands as well. If I want to make every section slightly larger in terms of the bold size, there are commands for that. If I want to reorganize sections, especially if I'm using the modular input/include commands, I can do that rearranging very easily. I often do this with figures, for example, where I define a separate file to define the figure, and then I can move the figure around quickly if I am trying to control where it is placed to some degree. And then also content. You can add working content as you go. For example, what if you have 3 versions of a title and you want to convey all of them and only have one build? Well, use comments to show the other ones. You can quickly comment and uncomment things and see alternatives. Maybe someone's editing the content. You want to show the old content in addition to your new content, right? A comment allows you to preserve that content. So you can have whatever kinds of content, both the actual content that you want displayed, as well as maybe I might call internal content in the document. Maintaining multiple options, keeping older wording type of thing. Another major thing here, again, this is, on smaller documents, you might not need modularity. You might not need modularity of the entire research effort, but you can organize your research as you see fit. You can utilize those input include commands to manage the complexity of a 100-page dissertation with multiple text files, for example, separate chapters, separate folders for those chapters, that type of, philosophy here. You can leverage comments. There are other approaches, but quite easy to just say, you saw those 4 inputs for each chapter. I'm writing chapter 2. I'll comment out chapter 1, 3, and 4. I can just see what I need to see. It will build faster. I don't have to worry about the unfinished chapters. you can use that from kind of a modular content creation perspective. Also, having multiple files does make it easier if you point them to it for collaborators to find the individual files that they have ownership on. I'm asking you to review this file, not the entire document. You can do that more directly here with kind of specific files, or you can say like, please fill in this file, I'll fill in this file. They could combine together to make your complete document. But it also allows you to organize more than just your text files, images and the methods to generate them. For a lot of times you might generate data, you might have code that takes that data, creates the figure. That figure is placed into, say, a figures filter. All that can be done within one directory of the research project effort, and you're able to reference them. I don't need to move a figure or copy a figure into my document. If I build it and there's a new version of that figure, it's pulling that new figure immediately in with no extra work on your own. So modularity from that perspective, in the sense, images, there's one version, that's the version is being brought in the document. Organize it as you see fit. Another thing that builds over time is reusability. Use things more than once. So it's natural to reuse packages and custom commands, right? As you understand which packages you like that are appropriate for your work, custom commands to do things you want to do, copy and paste, or have a file that is directly reused within multiple projects, for example, through the overleafs. It's the final bullet point that's not hidden yet. Overleaf supports reusing multiple files from other projects. The link is at the bottom for how to do that. Especially good for good files or responses, right? If you're doing a response, you have your journal paper and you do a response, you can just reference the journal paper that's in a different overleaf project in your overleaf project for the journal response, and leverage that single definition of the content and not have to copy it. But you can also reuse content and equations in different contexts. For example, you wrote a conference paper, you need to write a presentation on that conference paper. Well, you're just translating the conference paper content into a different context of a conference paper. So there are presentation tools like the one I'm using here to do that. You can whip up a quick presentation by just copying the required content from the paper into appropriate slides. Another major aspect of reusability, I think a lot of students like, is the single bib reference database. Or even, maybe you have a group reference database that gets built over time, where you have a well-formatted, complete entry in a bib database, right? For whatever organization you're submitting a conference paper to, you can change the style, but you can have the same reference database. The keywords, you don't have to keep learning new ones. You just keep reusing that structure that is in that single reference database. Another thing that I find is quite beneficial is consistency, especially in the confidence side, right? You can make consistent documents in other ways, but because of the fact that you define the section command and then there's a single definition of how that's formatted, you have a lot of confidence that the content is uniform as well as up to date. I just described the figure mechanism, for example. I know if I drag a figure and replace it or rerun code to generate it, it's going to be consistent with the most up-to-date version of that figure. Again, this is a natural consequence of letting LaTeX handle most of the formatting. There's lots of templates for conformity with formatting guidelines. And you can also define your own for your own research group or organization as well. For example, there's a link for NREL. NREL has their own templates for how they do reports and things like that. Your own research group could define those templates. My group had, at least the slide presentation kind of style, is one that I encourage my own students and members to utilize. And final point here, cross-referencing is always up to date again. Word and other tools have the ability to do this, but with this approach, you have confidence that that label, no matter where it's located, no matter how the equation is moved, you always have the correct cross-reference in the document. Okay. Automation, I've shown some of the things from the automation perspective, creating custom commands and doing things, and then using that wherever it's necessary. And then you can always change that command to rechange the formatting. You can leverage lots of different packages, for example, loading CSV data or creating QR codes, change the formatting of all similar environments in one go. There's a lot of ways to kind of automate things that leads to kind of efficiency. I argue that this is a flattened tool set. You're not clicking through menus trying to find out where things are. Again, once you know the commands and in the ways of doing things, it's, just writing that out. And you have, for example, the autocomplete to support this kind of, start writing, not having to deviate from that writing mindset. Many of the points above, I would argue, lead to efficiency improvements. Okay, collaboration is another major area. I've listed a bunch from kind of overleaf perspective. I'll mention that there's always the ability to just annotate the outputted PDF, as that is a common workflow for providing feedback. You have a PDF, you can provide comments there. So more traditional LaTeX approaches use comments, but also formatting commands. I'll show this in the example here. For example, I might define a formatting command that says, my initials, and it is so that someone knows that this is a change that I made. The text is red. I might have a star, so someone could just quickly search for stars and see that that is where edits have been made. This is a more classical LaTeX, collaboration, editing, feedback type of thing. You can visualize the changes. If I need to disable these changes, right? I change the color to black and I delete the star, and it's like the command is not there. And again, overleaf works like Google Docs, Microsoft 360 Online, real-time viewing of collaborators, things, comments, reply in the documents margin, built-in chat, etc. And this point I've skipped over because it is text-based. It works well with general version control, things like Git. So if you're trying to manage the code to generate figures, the figures themselves, other things in the research effort, in addition to the documents, you can directly say, look at a diff between two files and see the changes as well. Okay, I probably need to go through these pretty quickly. Learning curve, we're now in the challenges. So what you've seen is just a small preview of all the things it can do. And there's certainly a learning curve here. There's, as with any new process of doing something, there's certainly some upfront learning effort to be effective. So the efficiencies and things like that that I feel that I have comes from decade plus of doing this, rather than you'll have the same efficiencies if you just start today. So there are lots of resources in section 5 though to realize the benefits here, but a learning curve is certainly one thing here. Again, you're just about to finish your dissertation, maybe there's not enough time and it's not worth investing in learning this, but if you're earlier, maybe it is. Maybe you'll have some of the payoffs that we described on the previous slides. Another thing is errors. So because you're relying on the compiler essentially to render the document for you, if you do something wrong, you might not see anything come out, and you might not be able to interpret the error. The error might be, the error system is not us, is what I'll say. I have a comment on that on slide 29, but that's a fundamental problem, right? If you can't see anything and you can't figure out why you can't see anything. Now, collaboration again. So even with the points made on the previous slide, it can still be challenging for unfamiliar collaborators, it should say. Right? It can be very frustrating to not be able to provide or see your feedback for them. So again, I encourage you to consider the statement on slide 3. Are you going to get the feedback that you need to do the work that you need to do? Maybe they have some preferred approaches or ways to do provide feedback, but if you're writing the fundamental research in a way that cannot be reviewed by the people that need to review it, this is probably not the approach you should consider. So make sure you're considering the negatives of the collaboration aspect. Another thing is the grammar spell check. Due to the use of commands and other non-traditional, non-content, there are sometimes issues providing good spell check and grammar suggestions, right? If you have a command, the traditional approach is not of checking grammar is going to be like, well, you have a cite command. I don't know how to interpret that in the grammar context. Many LaTeX-centric editors know the commands or know that there are commands, so they're not going to say it's spelled wrong. And tools like Grammarly work with an overleaf, but again, they're not perfect because of this kind of fundamental challenge of going through the grammar, the automated grammar checks with commands built in. One thing that I do a lot is I just copy the formatted text into another program to review it in the formatted sense. Final thing is, if you are creating presentations, especially this is something that I dislike, and this is more of a PDF issue, is that you can't include moving images, both animated GIFs and video files. This is more of a limitation of PDFs than a limitation of LaTeX itself, but it does prevent me from recommending it for, say, class slides, because you may want to include lots of moving images or videos. Okay, so I have a slide on errors. I think I'm probably just over time. So there's some comments here on errors, as an example, right? If you misspell a command, it's just not going to produce an output. Or there's a command for compiling a document that will allow you to run it through even if a command is not detected. But this is just an example of an error. I have some advice on errors, and Overleaf in particular has advice on how to detect some of the more common errors at the bottom. So please look at that. You will certainly encounter them very early on in exploring, because you can do something very basic as flip 2 letters and it won't compile. Okay, so I have a bunch of resources, a bunch of learning resources here. I'll just shout out a lot of the examples were based on that first bullet slide. It's open source set of slides that they encourage you to remix. I've remixed them here because it was a really good set of examples and presentation. There's discussion on the bibliography side, especially if you want to know what fields and styles are available and how to create those BibTeX entries using some existing tools. There's a bunch of resources there. Some of my packages I encourage you to think about, more basic packages, more advanced packages, templates from a lot of organizations. Big mess because there's a lot of information on what is officially supported. I will state that some organizations do not officially support. For example, SAE, I don't believe has an official template, and COSI definitely does not have an official template, although last year my group made our own template that conformed to their guidelines and passed everything. So I'm happy to share that if someone is interested in using this with, say, in COSI, but not every organization supports this. So look it up ahead of time, perhaps, if you have a particular organization that you're trying to build this around. And then you can do this on your own machine. You don't have to use Overleaf. And some comments on how to build images with LaTeX, right? It's really good at formatting math. I really like Inkscape plus Tech for creating LaTeX vectorized images that can be included in your document. So some more information there. So this is a QR code / link at the bottom to these slides. Thank you for sticking around. Sorry, I went a bit over, but there's a lot of things I wanted to cover. I'm happy to stick around if there are still questions. Thank you.
Thanks, Dan.
Thanks, Dr. Herber.
Thank you, Dr. Herber.
Actually, I would much appreciate that InCozy template if you could share that.
Yes, the reason I didn't put it there yet is I'm going to try to clean it up a little bit to, again, it was almost a one-off. It needs to be, it's not going to be perfect. I'm not going to, discuss on if there's any issues with it, but it did work really well for us in terms of formatting within their guidelines.
Great, thanks.
I have a quick question, Dr. Harber. Any history of losing data in Overleaf?
I have not experienced losing any data in Overleaf. They do, if you go to their, they have some limits on how many files you can have. I think it's in the thousands. I don't think they have they have recommendations on how large your project can be, because if it gets too large, it doesn't compile well. And they do have a timeout. One of the premium features is a longer amount of time to compile your document. So especially if you're getting something like a dissertation level thing, it might take so long that it times out on the free version. Again, you can do it locally, where you can let it build as long as you want it to take. But I've never experienced losing of files. Again, another premium feature is linking with Dropbox or GitHub, so you can have those files, actually hosted and managed somewhere externally. But yeah, I've never experienced that, Lana, in terms of file losses. But it is, good to download the source files and archive them every so often, as is maybe good data practice in general.
Thank you.
Yes, and yes, there are ways to build chapter specific bibliographies. I think someone did put in the chat that there is a way there. I know there's a way. I suspect that there is specific packages again that do those type of things. Yes, I shared the slides. Yeah, so there is a way to do double column format as well. Again, for a lot of this, Google LaTeX double column format, and you will get good. One of the links I provided was the Tech Stack Exchange, specifically is the people who have been using this for a while are very knowledgeable and very wanting to help. So you can ask questions, or honestly, someone's probably asked a similar question and we'll have an answer there. So please look at that resources page to see some of those discussion areas where you can ask, but also just search for responses. Yeah, so I think let me know if there's any, yes, okay, any questions or miss? Okay, go ahead.
You granted a new dissertation template by the school that they have an issue with on that?
No, so yes, if you want to be, certain that what I added didn't have any issues, please go to the GitHub repository that is based on that. Again, some changes were made. For example, I switched from BibTeX to LaTeX because it has some benefits in formatting references. But as you know, as many in the group know, I don't think they're looking at it at that fine level of detail. We have the right formatting. We're not changing the way sections are styled or anything like that. There's a lot of flexibility. They're more concerned, and maybe others know more about what they're specifically looking for. But yes, you can change things that will not be allowed. So again, this is why you don't change the formatting too much. Focus more on adding content into the document. That's kind of the purpose for it.
I was asking about the bar references that you go from the average single page. If I could include that and my bibliography and references.
Yes.
But I'm not sure if the task will be able to do that.
Again, we've gone through about 5 in the group, right, who've done this. And I do believe Drew's dissertation had backrefs for both references. So you can say this reference appeared on these pages, as well as the acronyms and abbreviations, and no, again, I don't think that's something that they let us format it how you want. Like we picked IEEE Tran for the templates, you could pick a different formatting style. I don't think they have a preferred citation style for the dissertation template.
So for this is probably a format question for a publishable paper. For double columns, lots of figures won't work, right? They'll be too small to read in a double column format. So you would just in LaTeX, you would just create an appendix and stick them in there, right? And then reference the appendix.
So there is a way to do full text width figures. So you noticed how I had the section star in the structuring. Right, so this section star. So you can do essentially the same thing. Again, the star is it's actually a different environment. So figure star is a full text width figure environment in the 2-column format. So yes, you can define the traditional figure without the star is a single column float. Figure star is a 2-column, or it's really the 2-column plus the center float. So you don't have to make an appendix. You can use that the figure star environment to do a 2-column float.
So the figure would appear in like the left column, but it would be big enough to read?
Appear across both columns.
Oh, it appear okay. That's doable. I see. Okay, that makes sense. That makes sense. Thanks.
Same for tables as well. You can do tables can get long. So yes. And my goal is potentially to add more to these slides. So if you, again, I have a link to my group website where if it does get updated, I don't know how I'll update all of you, but these are good things to ask questions on as I'll think about adding some more notes here to hopefully make it easier for you to find some of these things that are available. Okay, well, maybe we'll release everyone from the room. Thank you for sticking around and the questions. Feel free to reach out, or again, I know many of you are already doing this in some capacity, so I encourage you to talk with each other if you're trying to figure things out. But thank you.